Now let's take a look at the standard form of a quadratic function. You probably should have already watched a video or done some studying on the vertex form already, because I would say that is the easier one to start with. But this one will now work on standard form. So I'm still interested in the same information that I was interested in vertex form, which was namely, what is the vertex, what is the axis of symmetry, and will this graph have a minimum or maximum point? Now, obviously this is going to be a little bit rougher because vertex is still HK. Like, that doesn't change just because we change the form. And I don't see an h or a k in this form. It's ax squared plus bx plus c. The significance of that then being we aren't going to be able to just look at the equation and immediately pick out the vertex. We're going to have to do some work for it. Now the way we're going to do that is by using negative b over 2a. Negative b over 2a is going to be how we find specifically the h value. Negative b over 2a is how we'll find the h value. Now that applies to multiple things here, right? Because remember, our axis of symmetry, for one example, our axis of symmetry is always x equals h. And so if our axis of symmetry is always x equals h, that means in the case of standard form, we can say our axis of symmetry is x equals negative b over 2a. That also means that we can say our vertex will start with whatever the value negative b over 2a gives us. Now what that doesn't tell us is what the other part of our vertex will be, what the y-coordinate will be. But if we have a function, if we have an equation sitting right up here, and we are able to find what x is going to equal, all we have to do is take that x value, plug it in to the equation for x, and whatever we get will be the y value we need for our vertex. In other words, you could write this as f of negative b over 2a, meaning we'll simply plug in whatever we get. Now, as you can probably already see, that is going to be a little bit more work than vertex form was. The good news is that for the last thing we're interested in, the minimum or maximum, this is not going to really be any more work. Because if you'll remember from vertex form, the way we determined whether we had a minimum or maximum point was whether the graph opened up or opened down. And that was based off the a value. Well, guess what we still have here in standard form? Our a value. So those rules are still the same. If a is greater than 0, meaning if a is positive, that tells us that the graph opens up, which means we will have a minimum point. If a is less than 0, meaning if a is negative, that means the graph will open down, which gives us a maximum point. So let's take a look at this example here. We have the function f of x equals x squared plus 4x minus 2. So that would mean that I have an a value of positive 1, because there's just always an invisible 1 in front of that x squared if we don't see anything else, a b value of 4, and a c value of negative 2. So if I use our formula, I guess, if you want to call it that, of negative b over 2a, well, my b value is 4, so the negative of 4 is negative 4, and then I'd have 2 times our a value of 1. Well, 2 times 1 is 2, so we'd have negative 4 over 2, which would give us negative 2. So right off the bat, that tells us our axis of symmetry, I'm just going to say AOS, which would be x equals negative 2. That also tells me half of our vertex, but I still need to find the y-coordinate. So now what I have to do is take that negative 2 that we found and plug it into the function, plug it into the equation for x, meaning this whole thing here. So if I did that, I would have negative 2 squared plus 4 times negative 2 minus 2. Well, exponents comes first in order of operations, and we know that any negative number squared becomes positive. So negative 2 squared would become positive 4. 4 times negative 2 would be negative 8, and the minus 2 is just, getting rewritten at this point. 4 minus 8 would be negative 4, and negative 4 minus 2 would give me negative 6, giving us negative 2, negative 6 as a coordinate point. Another thing that I'd want to know is whether this graph is going to have a maximum or minimum point. So I need to check the a value to figure out if this is opening up or down. Well, we have an a value of positive 1, so that means this is going to open up. And if the graph opens up, that implies that we will have a minimum point, giving us all the same information we wanted to find with vertex form.